So, oh, there we go. Okay, good. Well, my name is Rick Tucker, and I started wood turning in about 2016 after I retired, and been a member of the KC Woodturners for, I don't know, 3, 4 years, something like that. So I ran across some YouTube videos on metal spinning, and it kind of intrigued me. So I wanted to try it, and so I've made some bowls, and um, so I've kind of worked into it. I started out turning on a shopsmith that my dad had. And if anybody has a shopsmith, they'll know that it's not very friendly for wood turning. So, so I shortly after I started, I got an actual wood lathe, and so this was the first bowl that I ever made, and it kind of looks like an ashtray, but you know, I thought that was cool. So this was the second bowl that I ever made. And this is, the first one is polished. This one is the natural finish on the turning. And I've tried some other iterations. This is where I've taken and folded the metal back on itself. This one sits on the bottom, and I made another one where it actually sits on the outside edge. And then just yesterday, I was able to turn my very first hem on a bowl. So I'll pass these around, and everybody can take a look at them. Hem. So I've had a little bit of fun with it. I like turning wood, but the aluminum is kind of fun. What you need to spin metal, first of all, you need a lathe, a faceplate, a form. So you cut this out of wood. What I do is I've taken construction lumber, 2x10 and a 2x6 piece of scrap from a construction site. They're trying to get rid of it. As you can see, some of today's lumber is not the best, but that's how I started out making the chuck. This is a form, and they call it a chuck. And I think it's called a chuck because it's actually what drives the metal in the process. And I'm not going to cut a chuck today just for time consideration. Everybody here knows how to cut wood and to make a form. There's some considerations that that you need to think about, and that is, you need to determine how wide the base you want, the depth that you want the bowl, and then make sure that when you cut this, you have very smooth radiuses coming out of the bottom to the side and to the flange. And the form needs to have some draft. If you make it straight, you might not be able to get it off. So give it some draft so that when you're done, it will come off. Of course, some of the other things that you need besides the chuck is a special tool post. You'll need some forming tools, some lubricant, and some metal polish. And we'll talk about each of these as they come around to them. I want to talk a little bit about safety. First of all, we're going to be working with a piece of sheet metal. There's going to be burrs. So I encourage you to wear gloves. Turning the disc would be like a meat cutting saw. So be careful where your fingers and other appendages are, and be real careful. The burrs have sharp edges. Also, when I soften the disc, anneal the disc, I use a torch, propane torch. So be careful around wood and sawdust that you don't start a fire. And the main thing, if you consider you think something is not safe, and then go with your gut and don't do it. So you're responsible for your own safety, so be cautious. I've never had a piece of aluminum come out of the lathe. If it did, it might spin. There's not a whole lot of mass like a log coming out of the lathe, but you need to be careful. I wear gloves when I turn or spin, and a face shield. And I encourage, if anybody has any questions as we go along, please speak up, and I'll try and answer them as quick, best I can. Yes, we have one. How do I determine the size of the disc? Is it's kind of a trial and error. For this particular form, I'm going to use a 7-inch disc. If you had a smaller diameter, you would, of course, cut that down. And so I don't know that there's a formula for how to do it. Okay. As we spin it, the question is, does the diameter become smaller? Well, that's it. It may turn, what I do is I start out with 7 inches, but I'm going to trim it, so it actually becomes smaller anyway. Does it stretch? Yes, it does. You can stretch it. As you'll see when we start spinning, there's a couple of ways that you can spin. One of them is you can stretch the metal and make it thinner. The other way is you can stretch the metal and then you can compress the metal and keep the thickness uniform. And metal spinning is examples of metal spinning. You've seen these little aluminum reflectors on these clamp-on lights. Those are spun. There are the nose cone on a propeller of a Cessna. That's spun aluminum. There's all kinds of, you can use spinning when you have to make a small number of parts and you don't want to go to the expense of an expensive die to draw the metal. You can spin them. Some of these professional turners, their chucks will be made out of metal. They'll have sophisticated tools with two handles on them, and they can form them to fairly tight tolerances. And I've even seen CNC spinning machines, which that is awesome, and they can hold fairly tight tolerances. Yes, question. I'm going to cover that, but the first of all is aluminum. Is I usually buy sheet metal, and not a plug for them, but metal by the foot. You just tell them what size you want, and they'll cut it to the dimensions you want, and then I go ahead and cut it as a disc. I think there used to be a place in Johnson County that sold metal and might be a source. And I bought some stainless steel from a long time ago, but I don't remember the name of the company. Hmm? Air parts? It could be. I'm not sure. Uh, yeah, and you can. There's two ways to get a dish. You can get one preformed, and where they blank out the metal. The good thing about that, it's already round, and it's fairly straight. I kind of go to I buy the sheet, and what I do is I take a jigsaw. First of all, if Jack, if you'll show photo number 1, I take a sheet and I take a jigsaw and cut out the disc, and my compass has a sharp point on it, so I can scribe it. The metal comes with a decorative finish on one side, has a protective coating on it, and that's usually the inside of the bowl. So if I use my scribe with a sharp point, I'll put a dimple in the bottom of the bowl. So I put some layers of painter's tape on there so that I can hold the center without creating a dimple in the bottom of the bowl. I cut that out, and we talked about sources. The sizes that you generally use are 32 thousandths, 40 thousandths, and 50 thousandths. For probably a lot of you know about the sheet metal, but I've got some samples here. One thing about buying metal at Metal by the Foot, they have drops. When they cut out the sheets, they have leftover pieces, and they're fairly reasonable. This is 32 thousandths for $1.36. I bought a 15 by 48 for $17. So I'll pass out these samples if you would like to compare the thicknesses, if those that are not familiar with sheet metal. Sometimes. Well, you know, Woodturners, free is best, but and the pre-cut disc, talk about the pre-cut disc. I looked at one on the internet, and it was $7 for a disc. And so if you want to save money, and the other thing is you don't necessarily have to use aluminum. You can spin pewter, which is already soft. You can spin copper. You can spin silver, brass. Aluminum is, it's and the cheapest. You can spin steel, but you're going to have some horsepower to do that. So we showed the disc being cut out. When I cut out with a jigsaw, it's going to have burrs all over it. So you got your gloves on, go ahead, and I use a file and deburr that disc. Jack, photo number 2, please. So this is the protective coating from the disc. Go ahead and remove that. I would go ahead and deburr it before I remove the protective coating. If you don't, you have to heat the metal to anneal it. So if you leave the burrs on there, sometimes it'll leave a little bit of that plastic coating around the edges, and it will smoke and not smell too good. And you have to heat it with a torch, and if you leave that protective coating on, it will smoke and not smell very good. So, I've heard that. So be sure and take the coating off. You can peel out, yeah, it's just with your thumbnail. Photo number 3, please. So what we have to do before we turn the aluminum is anneal it. And Sean, annealing means to soften it, correct? Right. So we make it more malleable, which makes it bendable. So a little trick that I saw on YouTube was to take a Sharpie and scribble on it. And what happens, and use a regular Sharpie and not the industrial kind. When you heat the aluminum, the temperature that the Sharpie marking burns off is the temperature that the aluminum needs to be annealed at. So next photo, please. What I do is I take my disc and I made this little cradle. It's just a 1x piece of lumber, and I 2 nails at the bottom and 1 at the top, and I cradle that disc so it stands vertically. You can also, another way to do it is when you're cutting out your disc, you can leave a little tab on it and then drill a hole on that, and then you can hang it from a wire. I prefer to use this method because if it's on a wire, it tends to move around. So, and then you have to remove it later. So I just go ahead and do this. So the next photo, Jack, please. It's a video. This is using a torch to burn off the Sharpie. And I brought these photos because I didn't want to bring flame into a wood shop. It's the previous one. Yes. Yes. Okay. Well, the video, you can see that some of it is starting to burn the Sharpie off of it. And so once you go ahead and get the markings off of it, just let it sit in that cradle and air cool slowly in still air. Don't use a fan, just let it cool naturally. No, it probably takes 2-3 minutes. Yes. Next photo, please. So after you heat them, they will warp, and that's okay. We're going to form them anyway. So, and now would be the time that if you did use a tab, go ahead and cut that tab off. And the discs, they may not be round. I'm not real steady with the jigsaw. They're going to be kind of jagged, and that's okay too, because we're going to trim them once we put them on the lathe. And if you have any imperfections on the aluminum itself, the decorative side goes inside, but on the outside, the sides we're going to form. That'll take defects out of it. But on your bottom, you can use sandpaper, steel wool, whatever, or polish, whatever you need to clean that up. So the next thing we need, we have our chuck. We're also going to need a follower block. And this goes in the tailstock. And the disc will be mounted in between the two. We'll clamp the disc inside there. What I do when I cut these forms is I make the bottom a little concave. It's like on a wood piece, you want a little concave so it'll sit on 3 points and not rock. I also make the follower block a little convex to clamp inside of it. And also, I think by doing that, it helps center or keeps the disc centered. Okay, and then another thing that we're going to need is a special tool post. Now this is, I get a piece of round cold rolled steel bar, same size as the banjo. In this case, it's 1 inch. And then I've got a 1 1/4 inch square bar that is welded onto the post to form a T. And then I drill blind holes in the bar. And then I have half inch diameter rod that I bought at the hardware store. And so that drops in there so we can use these as a fulcrum for our forming tools. There's another design where people will drill through the square bar, but then they have a lathe and they turn a shoulder on the pin. I don't have access to a metal lathe, so this worked best for me, just to drill a blind hole and drop the pins in. I made the bar a little bit wider than the 1 inch diameter because for the weld. The considerations you have to think about is the length of the round bar. If it drops too far down, it will interfere with, if it sticks out of the bottom of your banjo, it'll interfere with the bed on the lathe. So make sure it's short enough. And then you have to take into consideration the swing of your lathe. If it's you have a large, can turn a large diameter, you may have to make it higher. So this is probably the most expensive part of the metal spinning process. And we'll see how these pins work when we go ahead and spin. Okay. One Way has these already manufactured. Okay. Do you know how much they would cost? Yeah, and you can get that welded. I had a professional weld that. You can probably get somebody at a muffler shop to weld it a little cheaper. If you have a buddy that has a welder, that would be good too. Okay, forming tools. I wasn't ready to invest in some high dollar forming tools, so I used what's on hand. This is a closet pole, which I have formed with smooth transitions. This is a piece of dowel rod, also has the smooth transitions, and I got a little smaller dowel that I need if possible. Jack, if you would show the next photo, please. These are some professional tools. Also shows that tool rest where it has the pins that drops down into the bar. Okay. And then, okay, the tool post, the next one is a cutter that's in a round holder. And then the next one is these are metal forming tools. They're highly polished. They have curved edges. They're spoon shaped. Some of them are flat, and they all have gradual curves blending into each other. And then the bottom one is a hemming tool. Once you get your spinning perpendicular to the axis. You can turn it and then use this hemming tool, which is a semicircular and a roller, and you can roll your hem around. They also make, and not shown, is ball bearing forming tools, which cuts down on the friction. You can make those or buy those. Also, I've seen the pliers. I'd never seen these advertised anything. What I did with these is I went down to Harbor Freight. I got angled pliers. I took and rounded them off so that you can grab the workpiece and turn it around to start your hem. Sometimes it works and sometimes it doesn't. We'll see if we're going to try that tonight or not. Okay, and then also in spinning, you need lubrication because you're going to have a tool rubbing against spinning aluminum. So you can use paste wax, you can use grease, anything like beeswax or anything. I'm going to use paste wax, and for those in the front, you're probably glad I'm not going to use grease. And then so now would be the time to go ahead and we're going to take our disc and mount it on the lathe. I don't know that you can see it, but on this disc, I didn't deburr it before I heated it, and there's little black spots where the plastic was. This is the decorative side. Basically blemish free. This is the open side. So we're going to use the decorative side inside. So we're going to put the disc in, the follower block will go in, and then we'll bring the tailstock up lightly because we have to try and center the tool. Usually what I'll do is I'll try and visually sight the disc in. And then bring the tool rest up and try to align it as best you can. That looks pretty good. So I'm going to be pretty much on center. I'm going to trim the disc now. I'm going to go ahead and clamp it down. Make sure we got it locked in. There's different ways. First thing I started out is using a file an old file that I cut the end off of. And I cut it at about a 10-degree angle. I've got a single point on one end, and I've got a flat cutting edge along the edge, and that works good. I've also taken a piece of 1/4 by 1/4 lathe tool, and it has a 10 to 15 degree angle cut on it, and I mounted that into a lathe. And so I can trim that. The 1/4 inch, the disc will wobble a little bit. The 1/4 inch will cover most of that wobble. I've also tried to make a single point out of oil hardened drill rod. I think the other two work better than this, so. So what we're going to do now is we're going to go ahead and trim this. Good idea. Face shield and gloves. Can everybody still hear me? Okay. Thanks very much for saying that. I talk about safety and then I. Okay, and this will be a little noisy, so bear with me. We're making chips, it's just not wood. This aluminum alloy is very gummy and it will build up onto to the cutter, so you have to knock that off every now and then. So let's see how we're doing. We've still got places that haven't cut. Generally, you can also tell by the sound when you're cutting all the way around. Yes. Yes, you have to crank the tailstock up pretty solid. It's about 570. Sometimes that aluminum really sticks on there. Okay, just a little bit more. This alloy is real gummy when you cut it. It wants to build up on the cutter face. Okay, that looks good. Now we have burrs on both sides of this. So what I'm going to do is take a file and just remove the burrs. I know cymbals are spun. I don't know about the musical bells. I know you can make a bell by spinning the aluminum. once you start spinning the soft metal, it work hardens. So if you're making a bell, it will actually make that ring because it hardens as you work it. So that looks, I got to take the glove off because you can just use your fingernail. Yeah, it's still got burrs on it. I don't want the burrs because, you know, that's like a saw. Okay. Okay, so when we cut wood, we cut on the center line. And when we're doing metal forming, we're going to form below the center line. We're going to put pins in. And so we'll actually use our tool post as a fulcrum. We're going to be going on the low side, and you position these pins how you need them. We're going to go down, and we can just rotate around on that tool post rather than going in and out on the center line like we do in wood cutting. So we have our tools. What we need now is some lubrication. And like I said, I'm going to use just plain old Johnson's paste wax. I'm going to lubricate the backside also because I'll probably use the second tool and then lubricate the tool itself. So as you're forming under the center line, your force is going down. If you were on the center line, you'd be going in and out like this, and that would be putting force on the banjo towards the tailstock. This way, when you're going up and down, you're putting force down on the bed. It will vector down into the lathe bed. So it's a little easier. You won't have your banjo moving around. So we want to check and make sure we got it nice and tight. Our banjo's locked in. Let's see. Okay, when I start forming, I'm going to want to start in the center. And what I'm going to do is I'm going to go start in the middle and go out towards the edge and then come back. We're going to try and stretch it and compress it and see how it goes. We want to try and keep the disc perpendicular to the lathe axis. And sometimes the metal will start wrinkling, so I'll use the other tool to try and keep the wrinkles out of it. So on we go. And I'm going to crank it up here. The speed's not bad. So I'm running about 900 now. So I'm going to start in the middle. I'm going to go down to the edge, and then I'm going to well, I'm already getting a wrinkle on it. A really bad wrinkle. A decorative finish. I'm going to try and take it out. If I can't get it out, we'll start another disc. So I'm going down, I'm stretching, and then I'm compressing. Keep your fingers crossed. I think maybe we got them out. Just in case anybody is wondering, it doesn't always work. So I'll let you pass those around. That one that's got the cracks in it, I actually stretched it too much. So let's try something different here. I am going to try and make a hem. Okay, we'll try the pliers and see how that goes. Okay. Okay. Nice thing about putting a hem on it is you don't have to deburr it. So I'll clean some of that wax off of there. And what we can do now while it's still on the lathe, I'm going to go ahead and polish it. And what I use is a product called semi-chrome. Comes in a little tube made in Germany and works for aluminum, chrome. Well, anytime you're working with aluminum, it's going to be very messy, as you can see. So I'm going to wear the gloves. No, the good thing about these, if they get caught on anything, they tear away, which brings up another point. If you're going to polish, use a paper towel, don't use cloth. If you have cloth and it catches on there, it's going to pull that cloth and you into the spinning parts of the lathe. If you get a paper towel catch, it's going to rip the paper towel. So put a little bit of this on there. Going to slow it down a little bit, not too much. Yeah, this stuff works really great. Turn it up, buff it a little. And there, you have an aluminum bowl. We'll take and shine up the bottom and the inside. and aluminum bowl. Any questions? Yeah. I guess if you formed them in your follower block, you could probably press them in there. Well, you can't get to it with a follower block on there. If you had cold jaws, I suppose you could do something on the bottom. Vacuum chuck, there you go. Okay, we'll polish this up and that's pass it around. You want to do a challenge for next? I think if anybody doesn't want to spin aluminum, I would say incorporate metal into a project. Yeah, a lot of options.
Okay, challenge next month, incorporate metal into your project somehow.
That's metal.
If it's shiny and it's metal, yes. All right, well, what a great demonstration, something personally I'd never seen before. So it opened my eyes to a whole new way to use the lathe, I guess.